Now, I want to talk briefly about the different types of sleep and the different levels of sleep and what those mean. Usually, when we look at somebody sleeping, we think of them as doing one thing, being asleep. But being asleep actually has many parts to it. And one of the reasons why it's important, it's because there are a bunch of things happening while you sleep. In your body is sort of doing a diagnostic, fixing any micro tears. If you're going through puberty, this is the time when your body makes you taller, things like that. But in your brain, there are a lot of things that are happening as well. And I want to hit some of these. So when you're awake, first of all, uh, you have what we call alpha and beta waves. That means if I put you in an EEG machine, remember the EEG machine is all those stickers all over your face and head that record how active the different parts of your brain are. Well, when you're awake, the activity tends to be quite high. And we call those waves alpha and beta waves. If you're just relaxed, like maybe watching TV or just having a nice stroll down the block, then you probably have a lot of alpha waves, which are quick. If you look at the red ones there, they're quick, but they're still pretty constant. um, as opposed to beta waves, if you're very alert, if you're doing a project, if you're playing a video game that's interesting and exciting, if you're going through a problem and you're trying to figure out what to do, then you're actually in beta waves, or you're going to show more beta waves. And beta waves, as you can see, are fast and sometimes very rapid in the way they move. Um, but when you start falling asleep, um, first of all, you're going to have a lot more alpha waves, but then you're going to start entering what we call theta waves. Okay, and so here you see the alpha waves, and you're still going to have alpha waves when you're in stage one, but you're going to get more and more theta waves. And theta waves, you might be able to tell, are slower. Your brain is less active. There's less thinking going on, things like that. Now, if I were to wake you up in the middle of your stage one sleep or in the middle of just theta wave sleep, there's a good chance you're going to tell me that you weren't sleeping. Maybe that you were resting your eyes. I like to call it grandma sleep. I was just resting my eyes, right? Even though you totally heard her snoring. Um, it's your brain is less active, but it's not quite in deep sleep just yet. So that's stage one. Now, when you enter stage two, now you get a lot more theta waves. And so you have your theta waves are almost entirely constant, except that every once in a while you see a little bit of that blue there where everything just speeds up or the activity of the brain speeds up. We call those sleep spindles. Essentially, you're in theta waves, your brain is starting to slow down dramatically, and then randomly it starts to activate really fast for just a little bit, and then it goes back into theta waves. You might have felt this every once in a while. You're kind of falling asleep, and then you wake yourself up because it feels like you're falling, right? And you have to like wake up to catch yourself. That's a sleep spindle that occurred. If you've ever been sleeping next to somebody else um, and they start randomly shaking their leg really hard, really fast, or they start sort of shaking their body or their arm really fast for just a few seconds and then they stop, that is a sleep spindle. And specifically, when your body moves like that, we call that a myoclonic jerk. Myoclonic jerks um, are related to sleep spindles, and also when you wake yourself up, those are related from sleep spindles. When you wake yourself up because you feel like you're kind of falling, right? So that is stage two. Eventually, you're going to enter stage three. And in stage three, we still have theta waves here. Um, so it's sort of slower activation, at least slower than alpha and beta waves, but we start seeing a lot more delta waves. And delta waves, you might be able to tell, are way slower than even the theta waves. Essentially, your delta waves are your deep sleep, and your brain is sort of in the least level of activity of your sleep pattern. If you're in delta sleep, there's a good chance I cannot wake you up. You're not listening or hearing things that are around you. If I manage to shake you out of a delta sleep, um, there's a good chance that you're going to be super groggy. And no matter what I tell you, the house is on fire, uh, something or other. If I let you fall asleep again, you're not going to remember that when you wake up in the morning or later on, because your brain is has so little activation that it's just not going to remember that later on. However, in stage 3, we still have a lot of theta waves. Let me come back. Theta waves, and there's still less than about 50% delta waves. Now, as the delta waves start to increase, and we enter stage 4, well, in stage 4, we have more than 50% delta waves, which means there is very little activation in the brain. Your brain is not working normally, or at least not normally the way it is when it's awake. Now, you get to your deep sleep, and a lot of people think that when you get to deep sleep, then you just stay there for 8 hours until you wake up. But that's not accurate either. We have these sort of patterns. And so once you get to stage 4, um, then after a while there, you're going to start going back up to stage 3, where we start seeing more theta waves, then back up to stage 2, where it's mostly theta waves, but you don't go back into stage 1, right? So you go back up there, but it's not stage 1. I'm not going to see theta and uh, alpha waves. What I'm going to see is I'm going to see a lot of alpha and beta waves. Essentially, your brain is activated like if you were awake. Okay. And we call that REM sleep. So I'm going to see a lot of alpha and beta waves. Your brain is super active. And why is it active? Because now it's doing diagnostics. It's going over memories, trying to transfer short-term memory into long-term memory, activating things like that. It might start doing, diagnostics on the body, seeing if things are working or not working, etc. And so it's during your REM sleep that you dream. Um, uh, if you have dreams, if you have nightmares, if you wake up, right? Let me see if I can. There you see some beta waves, and the red one there is alpha. And you see in the graph those little dots. Those little dots represent when you turn, when you switch positions as you're sleeping. So that tends to only happen during your REM sleep because your body is activated, because so is your brain. Um, and so if you were to wake up in the middle of the night, you're probably waking up during your REM cycle. If you wake up to go to the bathroom, if you wake up because you heard a noise, all of those tend to happen during your REM sleep. So what does REM mean? REM means rapid eye movement sleep. And the reason it's called rapid eye movement sleep is because if you look at someone's eyes while they're in REM sleep, their eyeballs are sort of twitching back and forth, just left to right, left to right, left to right, really fast underneath their eyelids. And so we can see that their eyes are actually moving really fast while they're sleeping. Now, you don't stay in REM sleep either. It takes about 90 minutes to go from REM to REM. So, from this REM cycle, uh, you go back down to stage 2, back down to stage 3, back down to stage 4 with mostly delta waves. And then you start heading back up to stage 3, to stage 2, and then back to REM. That takes about 90 minutes, about an hour and a half. If you are trying to take a nap, you want to take a nap that is going to either be around 15 minutes, 20 minutes, so that you don't get out of theta sleep, right? So that you stay there in your theta sleep, or that it's about an hour and a half so that you can go through a full cycle. If you wake up in the middle of your delta sleep, you are going to be very unhappy. Sometimes, what will happen is that you wake up in the middle of the night, in the middle of a REM cycle, and you go, "Oh, I feel so rested," and you feel really good. And then you realize that you still have a bunch of uh, time left. Maybe you have another hour or another 2 hours of sleep, and you go, "Oh, I'm going to take my 2 hours of sleep." And when you go back to bed, you your alarm clock ends up ringing in the middle of your delta sleep, and now you feel super groggy and tired and achy, and you think to yourself, "How is it possible that I'm more tired now? When I woke up an hour ago, I was super well rested, and now I'm super groggy." Sometimes people will tell you that if you sleep too much, it gets you more tired. That's not quite right. What's happening is that when you wake up in the middle of a delta sleep, you're going to wake up super groggy. So if when you wake up in the middle of the night, you only have another 45 minutes, it's probably better for you to just wake up and get out of bed, play with your phone for a little while until your alarm clock turns on. Because if you go back to sleep and your alarm clock wakes you up in the middle of a delta sleep, you're going to be super groggy and achy and tired, and you're going to hate having to get up. Now, um, as you go through the night, especially if you're good at sleeping 8 hours every night, your body will start getting used to it. And instead of hitting delta sleep or a stage 4 all the time, it'll stop doing that, and it'll start going down maybe to stage 3 for a little while, and then eventually it'll only shift from REM to theta, from REM to theta, until you wake up, hopefully, in your last REM cycle. And then you wake up and you feel just fine. So you have to go through all the cycles. If you miss some of the cycles, you're not going to be sleeping well. If you take some types of drugs, if you drink a lot, if you're drunk when you go to sleep, you're going to miss out a lot of the delta sleep. And so you're actually not going to be as well rested. And that's going to show in the morning. You're going to feel a little bit more restless. You're going to feel like you weren't really get enough sleep, even though you slept the full 8 hours. Um, you didn't really uh, get the deep sleep that is necessary. Some drugs do the opposite. Some drugs prevent you from getting your REM sleep, and that's also problematic. That's going to prevent you from um, uh, being able to remember things correctly, to shift short-term memories into long-term memories. It might affect your health, your diagnostic that occurs while you're sleeping. So you need all of these cycles in order to sleep well.